Welcome everyone. So in the previous unit, we learned how to solve the diode circuit for DC voltage considering off assumptions. When we make off assumption, we assume the diode is off and we replace the diode with open circuit, and then we uh, determine the currents. After determining the currents, what we did, we justified the problems. How did we justify the problem? We determined the P side voltage across the diode Vp, and also determine the N side voltage of the diode, which is Vn, and we did Vp minus Vn. If we found that Vp is greater than Vp minus Vn is greater than 0.7, our assumption is wrong, the diode is on, and Vp minus Vn is less than 0.7, our assumption is right, the diode is off. So in this problem, in this unit, we're going to find a way to determine the transition state voltage for any circuit. Or I can say we need to determine the minimum value of Vi at which the diode is at transition state. So in that case, our unknown value is Vi. So Vi is unknown value. For example, we have this circuit where we have a Vi whose value we are yet to know, which consists of a resistor R1 5K, and there is a diode, a silicon diode. The diode is oriented in upward direction. Notice the diode is oriented in upward direction. And there is a resistor R2 connected parallel to the diode. So again, so we have a circuit where there is at least one diode or one resistor connected parallel to the diode. So which means we cannot apply Vp minus Vn rule. Okay. Now, in that problem, what we have to determine? We have to determine the minimum value of Vi. The minimum value of Vi at which diode is at the transition state. The minimum value of Vi at which the diode is in the transition state. Why is that important? We're going to see why is that important. Okay, so we already know at transition state that voltage across the diode is 0.7 and the current through the diode is 0. So let's say our diode is going through the transition. So we replace the diode as if it is going to the transition. So that means we replace the diode with 0.7 and the current through the diode ID is equal to 0. Again, notice the orientation of the DC voltage source. We said it before, P side of the diode and the positive terminal of the diode must be in the same side. N side of the diode and the negative terminal of the voltage source must be in the same side. Okay, so this is our circuit. So again, I need to determine Vi. Remember, I need to determine Vi. I need to determine at what value of Vi we have this condition. At what value of Vi? Vi can vary any value, from 0 to, let's say, minus 10 to plus 10 or minus 100 to plus 100. But when it is fluctuating or changing, we can, whatever the value, we can select at exactly at what value we're going to have transition. So in our, since the diode is going through transitions, so we can say, and we know that the ID is equal to 0. If I apply KCL here, I1 equal to ID plus, sorry, I1 and ID is incoming and I2 is outgoing. That means I1 plus ID is equal to I2. And then ID is equal to 0 as the diode is going through transition state, which means I1 is equal to I2. So that means although there is a voltage source across the in that circuit, but there is no current. So which means I1 and I2 are same current, which essentially means R1 and R2 are in series connected, series circuit. R1 and R2 are effectively in series. Okay. So since a current is flowing, I2 current is flowing through the resistor R2, and the resistor R2 is connected parallel to the diode. Okay. So whatever the voltage the diode is going to have, the same voltage is going to have across the resistor. So since they are parallel to each other. So since the diode is connected in, since the diode voltage is 0.7 because it is in transition state, So that means the voltage across the resistor will be 0.7. In that case, since the diode orientation is in opposite direction, so the plus minus, so we can say BR2 is equal to minus 0.7. So since they are connected parallel to each other. All right. Now, since the diode is, since the resistor R1 and R2 are in series, we can apply voltage divider rule to determine the voltage across resistor 2, which is R2 divided by R1 plus R2 times VI, which is 0.7 because they are connected parallel to each other. So from there, if we, after making some calculation, we find out that VI is equal to minus 2.48. So what does that mean? So that means in order to make, in order to go through the transition state, so diode has to have a source voltage whose value is VI equals to minus 2.485. What does that mean? The polarity will be, so if you draw the real complete circuit, so it should look like this. VI is equal to 2.485. Okay. Now, if I want to, now the question, following question is that if you want to make the diode always on, what is the source voltage? What should be the source voltage? If you want to make sure the diode is always on, we have to apply a voltage which is smaller than VI. That means if VI is our transition state voltage, so in that case, now VI must be smaller than minus, VI must be smaller than minus 2.485 volt. Thank you.